All right, welcome back, friends. Um, Today is lesson 3 in chapter 13, dealing with right isosceles and equilateral triangles. Same idea as yesterday, learning some properties of a triangle, and then be able to apply those properties in solving problems. These hopefully are terms you're familiar with. If not, we'll make you familiar with them pretty quickly. This is theoretically a 3-day lesson. I'm not sure if it's going to go that long. We'll just do our best to give it a shot, and we'll see how it goes. If I got to stop at a natural break point at 10-15 minute mark, I will do that. All right, let's go. Okay, show that the sum of the measures of the two acute angles in a right triangle is 90 degrees. This is a right triangle. That is a right angle. If the triangle is 180 degrees total, and that's 90, these other two must have a sum of 90. Would you agree? I would agree. This guy would agree too. So they like using the bar models, which I think is actually fine for this. A plus C plus 90 is the 180 in a triangle. So A plus C is also 90, or A plus C is the 180 minus the 90 right there. All right? Does that make sense? Hopefully it makes sense. Boop, 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 boop. All the same stuff, just written in a, if that's 90, these two must add up to 90 because altogether they're 180. Yes. And there's the idea. The other two angles add up to 90. And they're always acute because they can't be obtuse, or right because we need two angles to add up. You can do this if you like. We're going to continue. The answer is yes, by the way. Okay. In the triangle ABC, A is a right angle. The measure of B is 60 degrees. Find the measure of C. Okay, if you see this as a right angle, all you're really doing to solve this is you're not doing 180 minus 90 minus 60. You're just doing 90 minus 60 equals 30. That's literally all they're looking for. Oops, always in the way. And I'm still in the way when I hit next. See? All right, 30 degrees. We got that? Let's see if I can hang out up there and be not a problem. All right, as always, the triangles are not drawn to scale. Find the unknown angle measures. Go, because I'm starting at about 3 seconds, and I think you can get ahead of me and do this quicker. 2, 1, go. All right, does that make sense? We know this is a 90, then we know the other two have to add up to 90. Okay, and the same with those two. Okay. So far, not so bad. Theoretically, I'm guessing I was thinking we should do something here. There's our right angle, whatever A is, whatever B is. A plus B equals 90. Did I do anything? Okay, boom. Oh, let's see what they're doing here. Now this is when the puzzle party starts. Okay, first of all, they want the measure of A, B, and C. Okay, so don't look at this line right now. Okay, but keep that right angle sign. So there's a right angle, there's 74, 90, 9 minus 74 equals 16. Okay, then is asking for the measure of B, C, D. Okay, so we just figured out that A, B, C is 16. I always like to label, not just put the answers here, but I like to write my angles in the shape whenever I can. So B, C, D. Wait, B, C, D. So now we've got this triangle right here. Let me do this for you. Yeah. Go with a thicker line so you can see what we're doing. We're dealing with two different triangles here. B, C, D. Now look at just the blue triangle. We've got a right angle and 16 and something here. And guess what? We already know that 90 minus 16 is going to be 74. This is where it gets fun. This is where it gets puzzling. But you can do this. Okay. Look at each set of three angles. Which ones are the angles of a right triangle, and what can you say about the angles of a right triangle? Well, if it doesn't have 180, or what doesn't have 90, it's not a right triangle. What can you say about the angles of a right triangle? Well, they add up to 180. The two, oh wait, is that 40? 42 is 90, 31, 59 is 90, and the acute angles. All three angles add up to 180, the acutes add up to 90, and they're acute. They're always acute triangles. You can't have an obtuse angle in a right triangle. Okay, so that those two kind of overlap. Oh, no, yeah, no, it's not an acute triangle. It's just a right triangle. Okay, for this activity, we're going to show that an isosceles triangle, the measure of the angles opposite the equal sides are equal. What? So in this triangle, this side here and that side there are equal. And that means that the two opposite angles, so that's the opposite angle for that guy, that's the opposite angle for that guy. That means if you measure these in degrees, those two are also going to be equal. Great, right? Use a ruler to draw your own isosceles. So make sure two of the legs are the same size. Label it A, B, C here. And then you can cut it out and follow the instructions on the next slide, which is going to be cut it out and fold it in half. Boop. So this is just your proof. If you make an isosceles triangle, cut it out, fold C over to B, those two angles are going to match up exactly. Cray, right? So let's see. Now this is going to get used in puzzles. Okay. In an isosceles triangle, you have two equal sides, and the angles opposite those sides are also equal. Okay. Find an unknown angle measured in an isosceles triangle. In triangle ABC, AB equals BC, and you can see that indicated by the single slash marks there. And the measure of B is 62. Find the measure of A and C. And she's telling us the measure of the angles of the opposite sides are equal. Pause me for 5 seconds, and then and try this, and then I'll walk you through it. Okay. Okay, so the rule we just learned is in isosceles triangles, opposite angles are equal. So if that side is opposite a 62-degree angle, the equal side is also opposite a 62-degree angle. And now we have to do 180 minus 62, and C should end up being 54. Did you get that? Let's see what, oh! I did it wrong. Oh, see, I'm not as perfect as I like to think I am. If you gave me the stink eye when I said 54, good, because it's 56. Oops. All right, 56, 62, 62 adds up to 180. Oh, they're getting more puzzling now, aren't they? Okay, same idea. Pause for 5. Oh, different idea, sorry. Then pause for 5. All right, hopefully you got this figured out. In triangle DEF, we have the two equal sides marked, DF and DE. That means angle F and angle E are equal. Find the measure of angles E and F. So what we're going to do is 180 minus 78. That's going to give us 102. And if those two are equal and add up to 102, we're going to do 102 divided by 2. And each one had better be 51, or I'm going to cry this time. Let's see how I did. Okay, add them up. You get the 102. 102 divided by 2. Yay! All right. Again, the biggest thing we've done here is 180 minus 78 and 102 divided by 2. The computation is relatively simple. It's the problem-solving element. Deciding what to do is the real thinking part. Okay. As always, triangles are not drawn to scale. Find the unknown angle measure. And more in these problems, you got to read. There is information that is valuable within the text. In triangle ABC, AB equals AC, and the measure of C equals 39. Find the measure of A. Well, says the measure of B. Oh, look, it's reminding us that the measure of B and the measure of C are equal because they're on opposite sides. So measure of B equals measure of C, which equals 39. The measure of A is going to equal 180 minus 39 minus 39. And that's going to give us, is that 102 again? 102. Now I'm starting to overthink myself. Let's see what happens. Oops. Got to be 102. Okay, do this one. Pause me and I'll meet you at the end in 5 seconds after you've solved it. I've had a delicious sip of coffee. Ready? Okay, we're starting to talk about D and F. Here's my hash marks marking or identifying an equivalence. So those hash marks are opposite equal sides. So the measure of D plus the measure of F is going to be 180. So the measure of D and F combined is 180 minus 74. So 180 minus 74 is 106. Then to find out, so that and that is 106. So you have to do 106 divided by 2, and you get 53 degrees. All right. Calling me crazy, but this stuff is kind of fun. Give me a second. I'm checking my textbook to see where I should stop today. Do-do-do-do-do-do. 26 might be. How about this? I think we're going to stop here. This is probably enough. Well, hang on. Okay, I checked my book. I'm going to leave this up to your teacher. But if I was pit stopping right here, I would assign workbook pages 1. Look at my textbook. 67 to 1. 70. Okay. There's plenty of work to do on those pages, some problem solving. I'd go find your IXL lessons to practice that, and then we'll come back tomorrow and we will wrap up the rest. Or your teacher might have you do both today. If so, not my problem. Sorry. But this is it, you guys. It's puzzles. It's puzzles. As always, we're just having a great big puzzle party here in chapters 12 and 13. Slow down and think. Remember all the rules. We're going to start putting everything together. You're going to see you're going to see lines on a point again. You're going to see angles on a line again. Not lines on a point. Angles on a point, angles on a line, vertical angles, all that jazz. It's coming. But right now, this is probably what your teacher will have you do if this is at a break point. But if not, always double check with them. All right, been a pleasure. I'm going to see you either in 2 minutes or tomorrow, depending on what you're asking to do. I'll be in the same outfit because I'm rocking it today. See ya.